All right, here's a physics acceleration or deceleration problem. Let's look at the formula for acceleration. That would seem like a place to start. So acceleration is equal to the change in velocity over the change in time. I'll come back to that in a second, but let's review what these three things are measured in. So if I list A, V, and T, T is measured in seconds, velocity is measured in meters per second, and acceleration is measured in meters per second squared. That's a dead giveaway of what you have here. So let's pick this problem apart with some, like that color right there. Now, I'm going to be circling a bunch of stuff, and then I'm going to be deleting it so it's not messy. This right there is acceleration. I know that because of this unit right here, meters per second squared. These two things are velocities. Now, I know I only have one velocity here, but this is also a change in velocity. So let's expand this equation out a little bit. This is the final velocity minus the initial velocity over the final time minus the initial time. All right, so if we figure out what we have here, we can do this. Specifically, the acceleration is going to be this. So we're going to go ahead and list this as negative 1.8 meters per second squared. The velocity, though, we need to break into two parts. So we got our final and initial, and they actually give us both. We're trying to find here the time. Our time is the question mark. We don't know. It says how long does it take. That's the part we're trying to find. The final velocity on this, most people will say, oh, it's the bigger number. No, it's not necessarily. It is when it's speeding up, but when it's slowing down like this, the final velocity is 0 meters per second. And that would explain, if you already tried this problem, why your answer is negative instead of positive. The initial velocity is the starting velocity, which was 9 meters per second. 9 meters per, let me do that again. That's a S gone wild, per second. There we go. So if we plug all this in, here's what this is going to look like. We'll have acceleration equals, let me rewrite this formula here, VF minus VI, TF minus TI. Okay. We know the acceleration is negative 1.8 meters per second squared. That's A. It's substituted there. On the top, I'm going to extend that line a little bit. We're going to have our final velocity, 0 meters per second, minus 9 meters per second, which is the initial. Okay, so it started off at 9, it ends at 0. The time we don't know, so we don't know. We're just going to put t down there. So now we have to solve this. So it's going to be negative 1.8 meters per second squared equals, on the top this is going to be negative 9 meters per second. On the bottom, t. Now, when you solve something like this, you take this number, make this here, you take this number divided by this number, all right? So this is going to be negative 9 meters per second divided by negative 1.8 meters per second squared. And I know that my answer is going to be positive. When I do this, I'm going to get 5. And I ask you 5 what? Well, it would be 5 seconds. 5 seconds. And here's why. Just want to show you how these units all play out here. If I look at meters per second and I divide that by meters per second squared, I would flip this second fraction. So it would turn into meters per second times seconds squared over meters. And now you can see what happens here. The meters will cancel. One of the seconds here will cancel one of the seconds up here, and there are like 2 of them. So one of them will cancel. The only unit left is seconds. That's why this winds up being 5 seconds here. All right. That's pretty much it. It's a simple problem, but executing it is complicated. Have a good day.